Well, thank you for coming. My name is Sean Casey, and I'm going to be presenting to you guys my DApp called VulcanSwap. A bit about me: I come from a full stack development background, making web apps with Django and Drupal systems, and building with React front ends. And now I've been contributing to Ethereum open source projects and building my own. And this is one of 3 blockchain courses that I've taken in the past 6 months. So VulcanSwap is a decentralized dollar cost averaging DApp, and I'll explain a bit later why it's called VulcanSwap. Will become more apparent to everybody. So crypto markets are inherently volatile. Price action is crazy. Paying attention and market analysis is very time sensitive, and investing is highly emotional. A lot of you guys have probably seen this graphic before, this famous psychology of a market cycle. Basically, everybody knows that the strategy should be to buy low and sell high, but emotions always get the better of you. FOMO and greed stop you from making rational decisions in markets that are just unpredictable. So one way to solve for this is to use a strategy called dollar cost averaging, which essentially removes the guesswork, time, and emotion of trading by allowing you to distribute your capital in equal increments over a constant time to average out the volatile movements. So for example, you could say use $1,000 to buy Ether in 5 batches, 1 time per week, no matter what the price is at the same time. So VulcanSwap then is the hashtag DeFi, decentralized finance movement. VulcanSwap is an emotion-free, decentralized dollar cost averaging tool on the Ethereum blockchain. And now we can understand why it's VulcanSwap, because it removes the emotion from trading, leaving only the logic of Mr. Spock's Vulcans, so you can go long and prosper. So there's a 3-step process in the way that the VulcanSwap handles its order book. So the first step is that user places an order, and they place this order on a website built on Drizzle and React, and then the order that they place is stored on the Ethereum blockchain. And next, a node script deployed on AWS serverless is loaded with an Ethereum wallet, and it sends a transaction to the smart contract to check if swaps are due. This kind of simulates a cron job, which isn't available natively in the Ethereum EVM. So this was actually like quite a challenging part, was figuring out how to institute cron in a centralized yet an innocuously centralized way. And we can talk more about that in questions if you guys want to hear about it. And the third step after the node script calls this method on the smart contract is that the smart contract sees if swaps are due, and if they are, then it will execute the swaps using Uniswap contract interfaces. The business model right now, it's only on testnet, so it doesn't really matter anyway, but the fee currently is just a flat 0.5% fee that's charged on each swap that's made. So if you have an order with 5 swaps, each time one of those swaps is made, 0.5% is charged on whatever the principal is. In version 2, I want to bring that down to 0% and make the business model completely about making interest on the Ethereum and DAI that's deposited into the smart contract. We can do this by loaning out the Ethereum and DAI that is yet to be traded. We can loan that out on Compound to accrue interest and give people the free service and still be making money. So without further ado, I'll give you guys a brief demo. So like all apps, the first thing we got to do is give MetaMask permission here to access. Then we'll see we have 100 ETH available, and we have no tokens yet. So we're going to create our first order. So let's enter 2 Ether. We'll pick our ERC20 token. I've created 3 tokens here for this demo, and it's on Rinkeby. So we'll choose the consensus token, which is the lube in honor of Joe Lubin. So on the right here, we see this brings up a liquidity pool pane that shows us some information about the token in Uniswap. So it shows us what the current rate is in Uniswap, and it shows us what the current liquidity is of the liquidity pool, which is important because we can't put in too much Ether if it's that much more than the liquidity. So then we can choose our swap frequency, which can be hourly, daily, weekly, or monthly. So we'll choose an hour for this one. And we'll set the number of swaps to 5. We'll vulcanize the order, and we'll send that off to Rinkeby. And then once it's confirmed, then we can see at the bottom under active orders the information about the order we just placed, the frequency. We see there's 0 of 5 batches that have been executed and nothing that's been converted so far, and no trades have been made yet. The next one is overdue. So now quickly, we'll just add 2 more orders so I can show you how this works once the orders are executed. So we'll add the Moon Unit token, which again brings up new liquidity pool information on the right. And we'll choose a daily swap, and it's going to be in 3 batches. So we'll send that order off. Great. Then we just have 1 more to do. So we'll do 1 Ether, swapping for Sean token every week. And we're just going to choose 1 batch for this one. Even though it doesn't make sense, it's just to illustrate what happens after all batches are complete. So now you can see we have all these orders that are ready to execute at the bottom. So this is when the AWS serverless architecture will fire off a node script that fires a method on the contract that then checks if orders are due and then swaps them. So you can see that, yep, it executed all the overdue orders. And now we have the number of batches that have been executed have been incremented. So 1 of 5 batches and 1 of 3 batches. And we've got some tokens here that have been converted. And you can see at the bottom now under archived orders, we have the 1 order that had just 1 batch has been completed, and the status is marked as complete. We can also cancel an order. So this order only has 1 of 5 batches executed. So if we cancel the remaining 4 batches, then that order will get moved into archived and marked as canceled, and the Ether will have been refunded into the user's account. So there's also an admin page with a bunch of options to manage this contract. So we'll just go to the MetaMask account for the admin here. And then we'll go to the super secret admin page here. And then now we can see some information about the contract, the number of orders that have been created and trades, the total Ether under management. And most importantly for us right now, we can see the amount of fees that have been collected. So under admin options, one of the first things we can do is we can withdraw those fees. So as long as we're calling this method from the admin contract, the admin account, once it's made, then the fee balance will drop to 0, and we will have had that deposited into our admin account. And it's kind of an odd number, so maybe you can't tell, but it has incremented. Then below that, we have options for transferring ownership of the contract and changing that AWS remote caller if we need to, and also about changing the minimum maximum values for orders. So over here, we'll change the number of batches to 2 at a minimum, because it doesn't really make sense to have 1 for dollar cost averaging. So we can see now that the minimum number of orders has changed to 2. So all of that enforcement is done both here and at the smart contract level, both in React and at the smart contract level. Cool. So the next steps for version 2.0 of VulcanSwap, what I really want to do is, like I said before, I want to integrate compound.finance. So by creating compound loans with all of the Ether and the DAI that's put into the contract, we can make interest and have our business model being just making interest off of these loans and just loan the money out when we don't need it, and then take it back into our supply when we actually need to execute these orders on the smart contract level. The second thing is I want to integrate DAI. So to really have dollar cost averaging, we need a dollar peg stablecoin. And DAI is the best one out there right now because it's the only truly decentralized, it's the biggest of the truly decentralized stablecoins. So having DAI as an input instead of just Ether would be awesome. And what really needs to be done before I were to push this to mainnet would be to get it all audited, because since we're actually transferring real value, it's a bit of a convoluted contract, so I need to make sure that the calculations are all doing exactly what they're supposed to do, that interest is being taken in a way that's going to leave a correct balance and account for gas and all this kind of stuff. So I'll need to get it audited before launching to mainnet. And yeah, VulcanSwap is live on Rinkeby testnet, and the contract is actually verified on Etherscan as well. So you can go to vulcanswap.seanjkc.com and try it out on Rinkeby. And if you're interested in hiring me in Prospering, you can check out the links below to LinkedIn, my personal site, and GitHub. And actually, I just recorded a lecture a couple of days ago about DEXs, decentralized exchanges, and about writing smart contracts with Uniswap. It was like a 45-minute lecture, and you can check that out on my personal site if you're interested as well. All right, thanks, guys. I'll take questions if you guys have them.
Go ahead and unmute yourself if you have any questions.
I have a question. Regarding the way in which the transactions are created in AWS, so what happens there? Is there a secret key stored there, or do you pre-create the transactions, or?
Exactly. So there's a publicly callable method on the smart contract that will have the smart contract loop through and see which orders are due and then execute them. That method can only be called by an address that's specified in the smart contract, which can be changed in the admin interface. So the remote caller actually then has a Ethereum private key loaded into the node script that's hosted on AWS Lambda. The thing is, like, running this script, it's totally innocuous. Like, someone could hack it and run it, a million times and nothing would happen other than just the Ethereum balance of that wallet going to zero. Because this function, all it does is it has a smart contract check if swaps are due. And if they are due, then it executes. But if they're not due, it doesn't do anything. So you could run it like a million times in an hour, and other than server and gas cost related problems, nothing would happen. So it's kind of like an innocuously centralized solution, if that makes sense. Does that answer your question, or do you have another question about the AWS architecture? It's basically Lambda that's queued with AWS CloudWatch. And then Lambda script just holds the private key of the Ethereum address. And then if anything were to happen to that private key, if it got hacked, then we could easily change the remote caller through the admin interface, and only the admin of the contract can change the remote caller, which is different from the remote caller's private key.
Okay, thank you.
Yeah, thank you. So I see some comments. Ed says MythX for security. That's a great call. I didn't mention, but I have actually already done, I've already run this through MythX and it all works fine. So what I'm worried about is not security so much as whether the calculations are going to always leave the principal in the smart contract that should be there for each of the users in case they were to withdraw or for the remainder of their order to execute based on gas and the interest that's being taken out in this kind of stuff. So it's more like the calculations of the bookkeeping that I want to make sure is working, the logic. Did you explore solutions like Chronologic to allow for easier transaction scheduling? No, not yet, but I will definitely take a look at that. I'm very interested in like these kind of alternative ways of scheduling and cron jobs and stuff on the Ethereum blockchain, because it's, I think, for developers of traditional architectures, it's one of the first problems that kind of becomes apparent is lack of like self-execution based on time, which is definitely important to develop some system for in Ethereum.
So this is Mike Salim.
Hey, Mike.
Hi, Sean. Great job.
Thanks, man.
Very nice.
Thank you.
You mentioned cron jobs and your solution to that. Tell us more about how you solve that problem.
Yeah, so that's what I was just mentioning a second ago with the AWS architecture. So basically, there's a node script that's deployed to AWS Lambda, and that script holds a private key for an account on the Ethereum network, and that account is preloaded with some just trivial amount of ether, enough to make these transaction calls to the smart contract. And so AWS CloudWatch is hooked into AWS Lambda, so that every hour on the hour, it will fire to AWS Lambda to run the script, and then the script will call or make the transaction rather, to send a transaction and call this method on the smart contract, which is responsible for checking all of the orders in the cost average order book to see which ones need to be executed, and then executing them through Uniswap. So it's done by AWS CloudWatch, triggering triggering the AWS Lambda scripts hourly, and then the AWS Lambda loaded node script calls a function on the smart contracts.
So you're really running a cron job on the wallet as opposed to the smart
yeah. So the cron job is done as it's like an AWS serverless cron job. You could look at it like that. So it's basically like CloudWatch is calling just calling this Lambda function in a predictable time interval, which basically simulates a cron job.
So this is dependent on AWS architecture then, correct?
Yeah, totally. But the thing is, like, you could remove it and you could replace it with anything else, or any user could just come in if we really wanted to and remove the qualification of the remote caller from AWS has to be the one to call it. Because this transaction really, like I said, it's totally innocuous, the method that it calls. So the method just will have the smart contract check and see which orders are due to be swapped, and only if they're due will it swap them. So I could put a button on the site, and actually that's how I was testing before I loaded this to Lambda to make sure it would work. You could put a button on the site that said check and execute orders or whatever, and then just keep clicking it over and over. As long as people are happy to be paying the gas for it, then it's totally innocuous and fine, and anybody can call that function. The only thing is we just need someone or some server to be predictably calling it at least once an hour. And so that's why we have the AWS solution in place. Does that make sense?
Yeah, thank you very much.
Sure. It's kind of how, like, if you had a smart contract for a living will, and you needed to ping the smart contract when you think someone is dead, and then if they're not, then the smart contract will say, okay, then like this time window starts, and if there's not a heartbeat from the person who we think might have been deceased, like whether it's an Ethereum transaction or whatever, in X amount of time, then the person who executed that first call to claim from the will be able to claim all the money. But you can claim all you want over and over and over, but because that time is built into the smart contract, it doesn't matter. Like if you call it over and over and over, it only matters when the time actually expires.